Hey everyone, and welcome. Today we're jumping into Google's Gemma, which is this really fascinating family of AI models. And they're changing the game by focusing on one super important idea, making AI not just powerful, but practical. So let's get right to it. This is really the question at the heart of pretty much all AI development right now. I mean, we see these models getting bigger and bigger, but does that actually make them more useful for you and me? That's the core challenge we're going to explore through the story of Gemma. And the team behind this whole thing is Google DeepMind. Now, they're at the absolute forefront of this AI race, but it's not just a race for the most powerful model on the planet. No, it's a race to create AI that's also efficient and accessible. This is all about a huge shift towards AI that can run on our own devices. It's something called edge computing, and it's a big deal because it's more private, it's faster, and it uses way less energy than those giant models that live in massive data centers. So, where does this story even begin? Well, it all starts with Gemma 2. And its whole mission was to tackle that very problem, this tension between size and power. The whole idea behind Gemma 2 was to prove that you don't need a gigantic, energy-guzzling model to get incredible results. The goal was to build something lean, really efficient, that could still go head-to-head with models 2 or even 3 times its size. It's a classic David versus Goliath story, and it's absolutely crucial right now, especially when we're all thinking about the energy footprint of massive AI. So you're probably asking, how on earth did they pull that off? Well, the secret sauce, and this is the really cool part, is a technique called knowledge distillation. Just think of it like this. You've got this massive, super wise teacher model, like Gemini. Now, instead of just making the smaller student model learn from a textbook, it learns directly from the teacher. The teacher gives it richer, more nuanced examples, which lets the student learn way more efficiently and become far more capable than it ever could on its own. And boom, this table just shows you the results perfectly. On the left, you've got Gemma 2 with 27 billion parameters. You can think of parameters as all the little knobs an AI uses to learn. And on the right, the much, much larger Llama 3 with 70 billion. Now just look at those scores. Across all these different reasoning, math, and common sense tasks, the tiny Gemma 2 is right on the heels of its massive competitor. It's just an incredible example of that efficiency in action. But solving the size problem, that was really just step one. The next major hurdle for AI was to break out of its text-only world. Because let's face it, our world is multimodal, right? It's text, sure, but it's also pictures, it's sounds, it's all kinds of different languages. So to be truly useful, AI needed to evolve. It had to basically develop senses, get better at languages, and dramatically increase the amount of information it could chew on at once. And that brings us to the next generation, Gemma 3. And this wasn't just a simple upgrade, it was a fundamental leap in what a practical AI model could actually do. The very first and probably the most profound change was giving Gemma the ability to see and actually understand the visual world around it. And this is just wow. Okay, on the left, you're looking at a photo of a pretty complicated restaurant receipt, and it's in German. Now look to the right. That's Gemma 3's response. It didn't just see the image, it read the text, it understood the currency, it pinpointed the exact line item for sliced meat, and then it went and calculated an 18% tip. This is such a practical, real-world task that goes so far beyond just generating simple text. It's amazing. So, to just quickly recap Gemma 3's big upgrades. First, vision, which we just saw in action. Second, it got way better at handling lots of different languages. And third, a massive long context window. Basically, think of this as the model's working memory. A bigger window means it can process and reason over the equivalent of a 300-page book all at once, without forgetting what was at the beginning. Now, it's really important to understand that Gemma isn't just one single model. It's an entire family, a whole toolkit designed for different needs and, crucially, different devices. This table gives us a fantastic overview of the whole family. You can see models as small as 270 million parameters, built to run right on your phone. Then you've got the 2 to 4 billion range for laptops and desktops, all the way up to those big 27 billion parameter models for powerful servers. And each one is built on either the Gemma 2 or 3 foundation, but it's tailored for a specific platform. This chart really drives that whole point home. The goal of the Gemma family is to make state-of-the-art AI accessible everywhere. It's about bringing AI out of those giant, power-hungry data centers and putting it into our daily lives, from the phone in your pocket to the laptop on your desk. It makes AI more accessible, more responsive, and way more personal. So, what's the big takeaway from all this? Why does Google's decision to make the Gemma family open models matter so much? What's the big deal? This quote from the research team, it just says it all. By releasing these models out into the open, the goal is to democratize access to these incredibly powerful AI tools. It's all about empowering developers, researchers, and creators everywhere to build on this tech and spark that next wave of innovation. And that leaves us with this final, really exciting question. As these powerful, practical AI models become available to literally everyone, from individuals to small businesses, it's not a question of if we can build amazing things anymore. It's just a matter of what will we choose to create. Thanks for joining me on this one.